we're going to keep looking at absolute value functions in a lot of different ways here. Let's graph an absolute value function. 3 times absolute value of x minus 2 plus 4. Now remember, the x minus 2, when we subtract in there, it moves it to the right. So our vertex, instead of being at 0, 0, the vertex moves right 2, and then the plus 4 moves it up 4. The 3 kind of gives me how steep those arms of the V are. It gives me basically a slope of 3. So right 2, up 4. Slope of 3 would be here, here. And then the other side is always a mirror image. Now, let's walk through this. What are the slopes? Well, one slope is 3 and the other one is negative 3. The vertex, this common point here, is the point 2, 4. All right. Now, technically, what we have is really two lines kind of put together, but only parts of them. Do you see that if I continued on, I'd have a straight line going this way? And if I continued here, I could have a straight line with a slope of negative 3 going this way. So what we're going to try to do is figure out what the linear equations would be for each of these and write this absolute value function as a piecewise function. So, using these slopes and using the vertex as a point on the line, let's use point slope because I love point slope. I hope you do too. Point slope says y minus the y value of my point equals m slope times x minus x1, which is the x value of my point. So over here on this side, let's do the slope of 3. Y minus 4 equals 3 times x minus 2. Now to write it in function form, I'm going to have to pretty this up a little bit. So that would be 3 times x minus 2 plus 4. Okay, good. All right, on this side, we're going to use the negative 3 slope. So y minus 4 equals negative 3 times x minus 2. All right, booyah. Okay, get it solved for y. So negative 3 times x minus 2 plus 4. 3 times the absolute value of x minus 2 plus 4. So the original function, f of x, was 3 times the absolute value of x minus 2 plus 4. It's like taking the positive and negative versions of the absolute value. Oh my goodness. Just like when we were solving them. That's crazy. Okay, so let's see if we can rewrite it more as a piecewise function. So that the part that's got the positive slope, the right side, is 3 times the absolute value of x minus 2 plus 4. But when are we graphing that? We're only graphing this portion. So that portion of the graph is from 2 on to the right. So that means we're only graphing that portion if x is greater than or equal to 2. Now the negative side, the left side of that v, is negative 3 times x minus 2 plus 4. When x is less than 2, that gives us the left side. So let's think, how could we write a little shortcut for this? Well, basically just change the absolute value to parentheses. And then just write the first one. The second one, you just change it to negative. And your boundaries here are right there at the vertex. That's pretty nifty. So now let's do one more. But first, we're going to review everything we do with absolute values in one problem. Let's solve the absolute value of x minus 4 is greater than 5. Remember, we take the positive and the negative option. So you've got positive x minus 4 is greater than 5, or the opposite of x minus 4 is greater than 5. On this side, that's easy to solve. That's x is greater than 9. Or over here, I multiply both sides by negative 1. That gives me positive x minus 4 less than negative 5. Don't forget to switch your symbol. X is less than, when I add 4, I get negative 1. And it says to make sure you write this in interval notation as well. I know how to write. X is greater than 9 in interval notation is 9 to infinity. X is less than negative 1 means negative infinity to negative 1. And we're going to union those. Now, here's the fun part. Let's see if we can get 0 on one side of that inequality. Okay, this is the same one we just did. If I get 0 on one side, I can do that by subtracting the 5. So get the absolute value of x minus 4 minus 5 is greater than 0. All right. What if we turn this into a function and graphed it? So let's graph the function f of x equals the absolute value of x minus 4 minus 5. So let's remember what all that is. The x minus 4 on the inside moves us right 4. And the minus 5 at the end moves us down 5. 1, 2, 3, 4, 5. There's my vertex. This one doesn't have a number out front, so that must mean it's that basic slope of 1. So here we go. And here we go. All right. Let's go back over here for a second. Let's rewrite this as a piecewise function. F of x equals piecewise function. Remember, we just did this on the other side. We're going to change the absolute value to parentheses. And so I'll get x minus 4 minus 5 on the top one. And then negative x minus 4 minus 5 for the bottom one. Now, this is so close to being pretty. I'm gonna make it pretty. That's really should be x minus 9. That looks a lot better. And this one, if I distribute the negative, I get negative x, and then that would be a positive 4 minus 5 would be a negative 1. Okay. And what are the boundaries for this again? What's the vertex? The positive slope side starts here at 4 and goes off to the right. So this is if x is greater than or equal to 4. The negative slope side is to the left from there. So it's if the x's are less than 4. Now, let's see. So that's writing it as a piecewise function. What are the zeros for this function? So if we look and see what the zeros, the x-intercepts are, I have this one's at negative 1 and 9. Hey, I could have actually seen that from the equation. What makes x minus 9 equal 0? 9. What makes negative x minus 1 equal 0? Negative 1. Ooh, that's nifty. All right. Use the graph of f of x to determine the intervals where f of x is greater than 0. I remember this one. F of x is greater than 0 is the part of the graph that is over the x-axis. So that's this part. What are the y values that, and the x values that give me those positive y's? Well, that's all the way here, up to there. But it didn't say are equal to. So I'm not going to include those x-intercepts. So it starts here at negative infinity. and then it goes up to -1, but we're not going to include it because it doesn't say or equal to. Then it starts back over at 9 and goes to positive infinity. Hey, that is exactly the same answer we got when we did it completely by hand. That is so cool. Hey, I've got a question for you. What do you think it would be? So I'm just going to change up this problem a little bit. What if they had said, what makes the absolute value of x minus 4 minus 5 equals 0? So what would make this function, the y's, equal 0? So zeros. That would have been -1 and 9 in the curly braces. What if it was the absolute value of x minus 4 minus 5 is less than or equal to 0? So think about it. The y's less than or equal to 0. That would be these underneath the x-axis. So what x values give me that part of the graph? -1 to 9. Miss Nice, does this mean we can look at a graph and solve any of these absolute value equations and inequalities? Yes, it does.